We spent some time last week reviewing how to solve rational equations. This week we're just going to go a little bit further in depth just to remind you of what we did and also look at one application question. So again, when we're solving a rational equation, the first thing we want to do, well, there's two things that we sort of want to do before we actually try to solve. One is to restrict the domain. So when I restrict the domain, what I'm looking for are what values can x not be because we can't have a denominator equal to 0. So I would set this denominator equal to 0 and say that x cannot be 1. Setting this denominator equal to 0 tells me that x cannot be negative 1, and of course negative 1 again here. So this is my restriction of the domain, is basically every real number except for those two. The next thing I want to do is find the least common denominator, which in this case would be pretty easy. I've got x minus 1, and I've got x plus 1, and each of those happens once. X plus 1 happens again here, but that doesn't mean we have to square it. It's for each term. So this is my least common denominator. It would not make sense for me to FOIL that out. It would actually make it much more complicated. Now I'm going to take each of my fractions times that least common denominator. Now, the purpose of me taking each term by the common denominator is that I'm always going to have something that cancels out, and notice that when it cancels out, I'm left with no more denominators, so everything is going to be a nice whole number. So I have 1 times x plus 1 minus 2x times x minus 1 equals 2 times x minus 1. And then I just have to do my distributive property to simplify it further. Because this is a quadratic, I obviously want everything on one side, so I'm going to move everything to the left side. So I'm going to write my negative 2x squared. I'm going to subtract the 2x, and I'm still left with that positive x on the left. And I'm going to add the 2, which gives me plus 3, and then equal to 0 because I've gotten everything gone on the right side. Now I want to factor this if I can, but of course I've got a negative leading coefficient, and I never want to factor when I do that. So I'm going to take out a negative 1. That leaves me with positive 2x squared minus x minus 3. And I will factor this. So this does factor into 2x minus 3, x plus 1. And of course then I'm going to set each of those equal to 0 to find my solutions. So x would be 3/2 and also negative 1. But now remember at the beginning we restricted our domain and said x couldn't be 1 or negative 1, so this solution doesn't make sense. So the only solution to this is 3/2. That's the only one that works. Here's another question. Of course this is an application question. We're dealing with something that is distance equals rate times time, so we're going to sort of use this as we go. We do know distance. The rate is unknown because that's what we're determining the speed. So that's my unknown. That's my x or my r in this case. The time, we don't know that either because we just know that the difference is 2 hours. So with two unknowns, it makes it a little bit tricky. But since I do know this distance equals rate times time, I'm going to set this equal to, I'm going to say that t is equal to d divided by r, which of course I did just by dividing each side by r. So this is what I'm going to use. And I know that the fishing boat that can travel with the current happens in 2 hours less time than against the current. So I'm going to use that with my time. So I could say with the current and then plus 2 would equal against the current. So that's sort of the relationship that I'm going to use moving forward. Because this is 2 hours less, I would have to add 2 to it to make it equal to the time that it takes against the current. So with the current, I'm going to use my time to be distance divided by rate. So with the current, my distance is 60. My rate is my unknown plus 2.5. So rate plus 2.5. And then of course I'm going to add 2. Against the current, my time is distance divided by rate. So the distance against the current still 60, but the rate is obviously you're going to be going slower because that 2.5 is working against you. So this is my equation, and now from here it's pretty straightforward. I'm looking for the common denominator. Let's go ahead and restrict the domain. So the domain is that r can't be 2.5 or negative 2.5. I'm going to take everything times my least common denominator of r plus 2.5, r minus 2.5, and that's going to be times every single term. For that first term, the r plus 2.5s would cancel, leaving me with 60 times r minus 2.5. For the 2, I don't have a denominator, so I would have this. And for my last term, the minus 2.5s would cancel, leaving me with 60 times r plus 2.5. Now I just have to do some simplification. In simplifying, on my first step, I distributed the 60, I FOILed out these two binomials and then multiplied their solutions by 2, and then of course I distributed the 60 again. As we can see, I'm definitely going to want to turn this into a quadratic equation in standard form, so that gives me the 2r squared on the left. I'll subtract the 60 from this side, which incidentally makes it go away on this side. And then I've got, instead of standard form, because now that my r's have all canceled out and I just have an r squared, then of course my c value, I'm actually going to switch up and turn this into, having this on two different sides. So I'm going to add the 150 over and add the 12.5 over, which would give me 312.5. Now the reason I did that is because this value went away. When I subtracted the 60r from the right side, it also went away on the left side, leaving me with no r to the first power. So this is using the square root property to solve. First, of course, I would divide by 2, giving me r squared equals 156.25. And then in my calculator, I would take the square root of each side and find that r is plus or minus 12.5. Now, of course, the negative 12.5 makes no sense in this case because we're talking about a rate. And so my rate of the speed or rate of the fishing boat in still water is 12.5 kilometers per hour. Now, if they asked us how fast is the boat moving with the current and against the current, if it was with the current, we would add that 2.5, so it would be 15 kilometers per hour, and then 10 kilometers on the way back by subtracting the 2.5. Here's just one for you to try on your own. So press pause, try this question, and then press play to check your work. Again, I would start by looking at the domain and saying that for my domain that x cannot be 5 and x cannot be negative 1. This incidentally factors into x plus 1, x minus 5. And so all three domains can be restricted, or all three terms, this is how I would restrict the domain. Then I would look for the least common denominator, which is of course going to be x plus 1, x minus 5. I'm going to take all three terms multiplied by that least common denominator. For the first, the x minus 5s would cancel, giving me 3x times x plus 1. For the second, the x plus 1s would cancel, giving me 2 times x minus 5. And for the last, the whole denominator would cancel, leaving me with just 2x squared plus 40. And then, of course, we just want to get everything on the same side. So I'm going to subtract this 2x squared from the right, and subtracting it from the left gives me x squared, 3 minus 2. For x's, I have a 3x. I'm going to subtract 2x from each side, which gives me just a positive 1x on the left. And then I've got on the right side a minus 10 and a plus 40, so I have a plus 30. I'm going to subtract that, making it a minus 30 on the left side. Now, of course, I'm just going to factor. That gives me x plus 6, x minus 5, giving me my solutions of negative 6 and positive 5. Again, we always circle back to my restrictions of the denominator. X cannot be 5, so 5 doesn't work. My only solution is x is negative 6.